Hi, I'm Rachel Klenke, and this is Bailey Bush, and this is our presentation on jet dyeing machine. First, we have a video on what the jet dyeing machine process looks like. The main process completed by the jet dyeing machine is piece dyeing. During this process, a piece of fabric is sewn to its own end to form a loop after being fed into the machine with a rope. Water, dye, and other chemicals are added via fill pump and added to the tank to create the dye bath. Jets with dye bath solutions push the fabric continuously to keep it circulating. A heat pump heats up the dye mixture, and the dye bath facilitates dyeing. The thermodynamics involved with this process are dispersion, absorption, heat exchange, and work. To start the dyeing process, the dye is first dispersed into water, and then the molecules disperse within the fabric. The solution is absorbed into the fabric before the molecules disperse. Heat is pumped into the vessel through a heat exchanger. Work is involved with this process and is being done by the system. On the right, you'll see a diagram of a jet dye machine and the steps and how it works, which we discuss in the next slide. In this slide, we have a schematic of the steps and processes in the jet dyeing machine. Jet dyeing is essentially a high pressure, high temperature modification of a winch dyeing machine. As you see here, the first step is the dye stuff and auxiliaries feeding container. This is then fed to the heat exchanger, which turns to the heat pump for circulation of the liquor, which then goes to a high pressure pipework before the dyeing drum, and last but not least, the winch. Jet dyeing machines can be operated even at high temperatures and pressures. Jet dyeing systems are fitted with cooling systems that have the potential for reuse of warmed water on the next dyeing cycle. Increased dyeing rates are results to quicker machine drains and fills, and more rapid heating and cooling. The latter decreases energy requirements for heating the dye bath, and then leads to reduced steam of boiler use, reduced fuel consumption, and fewer emissions of the atmosphere from combustion. Outputted fabrics also achieve a greater fullness and handle. Here you'll see the input and output specs. Typical fabric to liquor ratio is 1:5, and this is done via weight. The power of the motor used is 20 horsepower. The steam pressure is measured at 4 kilograms per centimeter squared. The weight that a jet dye machine can hold is 150 kilograms of fabric with a circulation speed of 60 to 300 meters per minute. The maximum working pressure is 0.4 megapascals, and the maximum working temperature is 150 degrees Celsius.
Inefficiencies in the jet dyeing machine come from not only the inability for a heat exchanger to run at 100% efficiency, but also from the transferring of dye and other solution from the prep tank into the main part of the machine. Extra work and heat is needed to heat the solution from the prep tank when it's added, and the opening of this front loading port causes the release of heat and pressure from the machine, which causes the machine to work harder to maintain the temperature and pressure within the system. And sewing the fabric tube shut. So if this fabric is not sewn in rope form, or if it is sewn in rope form, then water and dye will get stuck inside of it and create a heavier fabric that's much harder to push through. So to solve this, heating the dye before adding it into the prep tank and refraining from opening the front port after it's been loaded will definitely help with the efficiency of the entire system. This machine has several impacts. Starting with the economic impacts, it has a short drying time and high production, However, the maintenance costs and initial investment for this machine are high, and foaming can be a problem, as well as some fabrics being abraded, which will cause damage and or costs later on down the line. Socially, these fabrics are handled carefully and gently, and rethreading is quite complicated. As far as environmental impacts, it has a low consumption of water and low liquor ratios as compared to other jet dyeing machines. However, foam forming substances are to be avoided. They don't drain as well as a typical liquor will. Here we have calculations for enthalpy and entropy, and we've used delta S is equal to delta Q over T for the enthalpy, with our delta Q being calculated on the next slide, but our temperature is 140 degrees Celsius for the calculation. And for enthalpy, we calculated it as H is equal to U plus PV, in which P and pressure is here, but the volume is on the next slide. And our enthalpy is listed here as 253.3 BTU. So for calculating the work or heat exchange, we used a dye ratio of 5 grams per liter of the bath, and with a fabric to liquor ratio of 1 to 5, we ended up with 750 liters in the bath, and the amount of dye being used as 3,750 grams of dye. We assumed a constant temperature and that the system was closed with a changing volume. So we were able to equate Q to W, where W was equal to P times delta V, calculated here. And the final and initial volumes listed here are in regards to the dye bath, because the volume of the machine is not changing. Thank you.